Hello guys, before moving forward, let's take up a question related to potential energy. In this question we have been given a ball of mass 500 grams that is thrown upwards with a velocity of 5 meters per second. We have been asked to calculate the potential energy of the ball when it is at the highest point. So we will see what happens in this question. A ball here, it is thrown upwards with a velocity of 5 meters per second. It reaches some height, let's say I denote this height by h. Now I have to basically find this h in order to calculate the potential energy of the ball. The potential energy of the ball at the highest point will be mgh. Now I know the mass of the ball, I know acceleration due to gravity, all I have to do is find h. So how am I gonna do that? I will use the formula v square minus u square equal to 2gh. At the highest point, final velocity v will be 0. The initial velocity is given to me as 5, so 5 square is 25 equal to 2 into 10 into h, negative times. I am considering downward direction to be my positive direction. Therefore, the height which is measured from the bottom to the top will be a negative. Hence, I have put a negative sign here on the RHS. This gives me 20h equal to 25, which implies my h is 5 by 4 meters. Now, I calculate the potential energy from this, which is mass 500 grams. I convert it into kg. G is 10 meters per second square into height is 5 divided by 4. I do some calculations and what I obtain is the potential energy of the ball is 25 upon 4 joules. From this question we can easily see that how our equations of motion can be easily related to work and energy. All that has to be done is we have to find the unknown quantity, in this case was h, and substitute it in the formula to find the potential energy. So these are pretty simple questions. Now we move on to conversion of energy from one form to another form. Energy can be converted from one form to another form. In this picture here, the solar energy is converted into electrical energy using solar cells. In the second picture, wind energy is converted into electrical energy using wind turbines. The third picture shows how electrical energy is converted into light energy and heat energy by an incandescent bulb. And the last picture shows how chemical energy is converted into light energy, heat energy, and sound energy. Now we see law of conservation of energy. According to law of conservation of energy, total energy of a system always remains constant. It changes from one form to the other form. Whenever there is a transformation in a system, total energy before the transformation is equal to total energy after the transformation, which is well stated by the first statement. Now suppose an object is released from a height h. At any instant during this motion, we have mgh plus half mv square is constant. Here the first term mgh is my potential energy term. The second term half mv square is my kinetic energy term. So the net energy, potential energy plus kinetic energy, I will write it here, potential energy plus kinetic energy remains constant. We will use the question we just took a little time back to validate this law of conservation of energy. So again I have a ball of mass 500 grams. In this case it is released from height of 5 meters. So therefore what I will do is first calculate the potential energy of the ball. We have been asked to validate the law of conservation of energy at point of release and the point of impact of the ball from the ground. So at point of release velocity is 0, therefore its kinetic energy is 0. The total energy that is present in the ball at that point is its potential energy, which is given by mgh. So this will be 500 upon 1000. I'll convert the mass into kg into 10 into height is 5 meters. So I do some calculations to get potential energy to be 25 joules. Now at the point of impact, my complete energy, the total energy will be the kinetic energy, because the height at that point will be 0 and hence the potential energy will be 0. So the kinetic energy at point of impact will be half mv square. Now the point is to find velocity. Now how to find the velocity? Velocity can be found out by v square minus u square equal to 2gh. Here, initial velocity u can be considered 0 because the ball is released from rest. Therefore, v square is 2gh, which implies v is under root 2gh, which is nothing but 2 into 10 into 5 under root, which is 10 meters per second. Now I calculate the kinetic energy, which is half into 500 divided by 1000 into the velocity that I obtained, 10 square or 100. Now I again do some calculations, and what I find out is the energy again comes out to be 25 joules. Hence the initial energy, the initial total energy and the final total energy are both equal, and hence it is constant in this case, which is 25 joules. Hence the law of conservation of energy is validated in this case. Now let's move on to rate of doing work. The rate of doing work, or in other words power, is defined as the rate of transfer of energy. If an agent works a work W in time t, then power is given by the formula power equal to work upon time. The unit of power is watt and is represented by the letter capital W. 1 watt means 1 joule of work is done per second. The power of an agent may vary with time. This means that the agent may be doing work at different rates at different intervals of time. Therefore, the concept of average power is useful. We obtain average power by dividing the total energy consumed by total time taken. I will take up a question to make you understand what it means. In this question, a boy of mass 50 kg runs up a staircase of 45 steps in 9 seconds. If the height of each step is 15 cm, we have to find his power. So in order to find out the power, first I need to calculate the work done by the boy. To calculate the work done, which is nothing but force into displacement. So force in this case is weight of the boy, which is 50 into 10 or 500 newtons. And displacement is 45 steps, and each step is 15 centimeters. Therefore total displacement is, I'll directly write work is 500 into displacement is 45 into 15 divided by 100 for converting it into meters, which is 5 into 45 into 15 joules. Now having found out the work, we can easily calculate the power, which is work done upon time. The time given in this question is 9 seconds, therefore the power will be 5 into 45 into 15 divided by 9. I again do some manipulation to get power to be 25 into 15, which is 375 watts. Therefore, for a boy of mass 50 kg to run 45 steps of 15 cm each in 9 seconds will require 375 watts of power. Now we move on to the last topic of this chapter, the commercial unit of energy. The unit joule is too small and hence is inconvenient to express large quantities of energy. We use a bigger unit of energy called the kilowatt hour. 1 kilowatt hour is the energy used in 1 hour at a rate of 1000 joules per second or 1 kilowatt. So here is the calculation. 1 kilowatt hour is 360000 joules. Therefore, it's quite a huge quantity. The energy used in households, industries, and commercial establishments are usually expressed in kilowatt hour. Electrical energy used during a month is expressed in terms of units. Here, 1 unit is nothing but 1 kilowatt hour. Let's look at a question before completing this chapter. We have been given an electric bulb of 60 watt which is used for 6 hours per day. We are asked to calculate the units of energy consumed in 1 day by the bulb. So in order to calculate units of energy consumed, we have to first convert this power 60 watts into kilowatt hour because the 1 unit is equal to 1 kilowatt hour. So what I will do is first calculate the energy consumed in kilowatt hour and I'll write it equal to the energy consumed in units. Therefore 60 watt is nothing but 60 divided by 1000 kilowatt, which is 0.06 kilowatt. Now I calculate the energy in kilowatt hours consumed by the bulb per day, which is 0.06 into 6 kilowatt hour. This is 0.36 kilowatt hour. Now 1 kilowatt hour is equal to 1 unit. Therefore 0.36 kilowatt hour will be equal to 0.36 units. Hence, the bulb consumes 0.36 units of energy per day. With this, I end the chapter on work and energy. Thank you.